once again, hello, how are you doing? Welcome once again to another math video with Mr. Woodford. I'm very excited to continue to work on Unit 3 with my Math 8 students. So today we'll be starting our Unit 3, um, uh, which is talking about non-proportional relationships. So far we talked about proportional relationships and some key factors in terms of the equation being y is equal to kx. But today we're going to dive into a little bit further into understanding, okay, what is a non-proportional relationship? What does it look like on a graph? What does it look like as an equation, right? So if you have your packet with you, please open up to 3.1. If you're joining me on Google Classroom, once again, look on with us on lesson 3.1 as well. And let's look at it together. All right, as custom for every worksheet, I'm gonna give you a few minutes right now to begin to work on the bell work. I wanna give you time to work on the bell work, which would allow you to complete once you're done, obviously you're set to go, but pause the video right now. To begin to work on it, you have to graph this equation, identify M, graph the second equation, identify M, talk to me about where it's going, and then graph it on the coordinate plane. So pause the video now. Okay, awesome. I'm hoping that you had time to pause the video. Now, this beginning part of our bell work is actually a refresher of us understanding proportional relationships. Okay, I want to dive right in because there's a lot to go over in this lesson, so please bear with me. All right, I would take notes if you needed any edits and annotations that I make on the actual worksheet. Please do it on yours as well. That way, when you look back, you'll be able to remember what we did. So first, to start off with, I want to discuss. Okay, let's go over the bell work. The slope of the first equation is -2/3. That's right, -2/3. If you wrote that down, then yes, you did get it correct. Now notice I am not putting the x there. I'm just putting the number in front of x. That's a big thing. Do not put x where the slope is. The slope is only the number, coefficient, term, and constant in front of x. So in this case, it's -2/3. What I like to do in class is I like to show the direction that this is moving. The -2 means we're going down, and this bottom number is always going to move to the right, always moving to the right. So we're going to go down to right 3. And that just tells you that the graph goes 2 units down, and then 3 units to the right. And we're just always moving to the right because it's going to make it easier for us to graph it, okay? Before I go to graph this equation, let's fill in the data for the second one. The slope here is 1/4. What does that mean? That means it goes up 1 to the right 4. Up 1 to the right 4. Okay. The graph goes how many units? In this case, it goes 1 unit up. Now, why is this one going up and that one going down? Remember, this was a -2. This is a +1, so that means this one's going up. And then it's going 4, and like once again, we're always moving to the right, 4 units to the right. Now, for you to be able to differentiate between these two equations, what I want to do is actually, I'm going to graph them different colors. The first one, I'm going to graph red. The second one here, I'm going to graph green. Right now on your paper, you won't have these colors, but you want to make sure you're very precise, and you also label as I'm going to show you as well. Now, with these graphs, because they're proportional, right, and they do not have something we're going to talk about later today that differentiates between proportional and non-proportional, we're going to start at the origin. We're always going to start at the origin at 0, 0 for proportional relationships. For proportional relationships. That is not what we're working on today, but it's a good refresher to say, okay, I'm going to start at 0, 0. Now, this graph tells us, I'm graphing the first one, which is red. It tells me it goes down 2. So I'm going to go down to, now you could make the sketches, right? Like I could do here, I can go 1, 2, but I'm not going to stop there and put a point because it says it goes over to the right 3. So I'm going to go over 3, 1, 2, 3, and this is where my new dot's going to be. So notice that all these, all the sketch marks that I created, I actually do not need them, and it's preferred that you actually do not even include them when you're actually going to edit. So I'm actually going to erase them. Just because I want to make sure that you don't get into the habit of showing me those sketch marks, okay? The next point that I'm going to put here, I'm not going to do those edges. So once again, I'm gonna start at the origin, right? We start at origin, we go down 2, 1, 2 over 3, 1, 2, 3. Now, a misconception is to go back to 0, 0 or go to somewhere else and try to do the pattern again. No, do the pattern again from the point that you left off at. So since we left off at this point here, I'm going to start from here and go down 2 again over 3, 1, 2, 3, and make my new point. And I could do it again, but I'm starting from this new point now, down 2 over 3, 1, 2, 3, and I make my new point. Okay, and this is how I create my proportional line. Now I could go back to the origin and do it the reverse, do it the opposite way and going up 2 instead of down 2. Instead of going to the right here, I would go to the left. Okay, this just helps me to fill in the graph fully, to go from one end of the graph to the other end of the graph. Okay, so you can see a nice straight line that is occurring here. So after you create these dots, and it is mandatory that you do create these dots, do not like, okay, that was optional. No, making the dots is a mandatory thing. Make the dots, make them nice looking, so that way you could create a nice, beautiful line that goes through everything. So here I'm going to make a nice line, okay, and I'm going to finish up my line here. I'm going to put arrows at both ends. The reason I put arrows at both ends is because I know the graph keeps going. It does not stop here. It keeps going. And the only way I'll tell the difference between this equation and other ones is if I actually write the equation here, -2/3 x. So that's my first equation that we got here. So when you want to do this on your own, you should have recognized what the slope was -2 over 3. It goes down 2 to the right 3. And then you should have been able to realize, okay, this is proportional. I'm starting at 0, 0. I'm going to go down 2 to the right 3, down 2 to the right 3. And then you're going to make this beautiful graph that we just did. Now let me graph the second one with you. And once again, I said I was going to graph this one in green. So let me graph this one in a green color. Okay, and once again, as all proportional relationships, I'm going to start at 0, 0. So starting at 0, 0 here as well. But this one says go up 1. And once again, I'm just going to do the sketches for this first time. Up 1. And then to the right, 4, 3, 4. And this is going to be my brand new point. I'm going to do that again. Up 1 to the right, 4. It's going to give me a new point right here. I am going to erase those sketches. Let me just do it in the opposite way as well. Okay, down 1, and I'm going this way, 4, and boom. These are my new points for this brand new line. Now, I'm going to get rid of those sketches. In addition to also getting rid of the sketches, I am going to draw a nice straight line. If you have a ruler, you have, you know, actual like straight edge of some sort, and you want to use that to create your nice straight line, go for it. That's perfectly fine, right? Right, I'm going to create my nice straight line. Okay, and once again, I am going to put arrows at both ends because I do want you guys to remember that these lines do not stop here. These lines keep going. They go on and on and on. But the only difference I can tell the difference between this line and the other line is if I label it. You have to label it. Even if you don't have the colors like I do here, you labeling it lets me know, okay, that's that equation, that's this equation. Okay, so that's very important. So this is what we should have done for our bell work. And I know it's a pretty lengthy bell work, but nonetheless, I believe that you should have been able to get this complete in 5 minutes, okay? Let's go on to what we're doing today. So today we're gonna be talking about non-proportional graphs. These are proportional graphs that we're looking at here in our bell work. But the non-proportional ones we have to look at is gonna be talking about a very significant thing, which is something called slope-intercept form, which is a little bit different than the form that we see for proportional relationships, right? And we're also going to be talking about something called the y-intercept, which is inside of the slope-intercept form. So as usual with the vocabulary, every word goes into the first sentence. I do not try to switch it up. The first term goes in the first part, second term goes in the second sentence. So let's read them together. A linear equation written in the form y is equal to mx plus b. Now, if I was you, what I would like you to do is I would like you to highlight that. That's an important part of our lesson today. Y is equal to mx plus b, okay? This is the equation that we're gonna be looking at, all right? This is known as the slope-intercept form. This is known as our slope-intercept form. So if you want, you can write that right in. For the sake of it right now, I'm just gonna draw an arrow from this word down here, just to let you know that that's where this word goes. That's the slope-intercept form. Where the second sentence says the y-coordinate of the point where a graph of the line crosses the y-axis is known as the y-intercept. So y-intercept goes here. And now I want to explain something to you. Okay, so far, when we've been looking at equations, we've been looking at equations that are proportional, which as you can look at the two that's above, they're in the form of y is equal to kx. We're going to be looking at equations that's in the form of y is equal to mx plus b. All right. We, as a review for you guys, remember we talked about k being the constant, and in this case, m is our slope. Now we have a brand new letter included here, which is b. Believe it or not, this b is known as the y-intercept. This is what's going to make the difference between a proportional relationship and a non-proportional relationship. And you're probably like, okay, well, Mr. Warford, what is a y-intercept? When you guys think of intercept, you could think about the word interception, right? You could think about football. You could think about where the ball is being thrown in one direction, right? All of a sudden, the catcher catches it and they run in the opposite direction, or they get in the way of the actual path of the ball. That's kind of what a y-intercept is. It's where the actual line is cutting in the way of the y-axis. So if you think about the y-axis, right? And I'm just going to draw a quick picture here. This is our y-axis. This is our x-axis, right? If I was to say, okay, well, what is a y-intercept on these graphs? A y-intercept is pretty much saying that the line, the new line that we're graphing, is going to make a mark or cut through the y-axis. So for example, let me just draw a nice line here on these little axes that I drew, something like this, right? Where would the y-intercept be? The y-intercept is wherever that line crosses the y-axis, and you and I both can see that that point is right here. Okay, that's right there. So it crosses the y-axis at that point. That point will be considered the y-intercept. Now I'm going to obviously go into it in more detail, but I just wanted to give you a perspective as to, okay, y-intercept is where it crosses the y-axis, right? And that's the major difference between a proportional relationship and a non-proportional relationship. So let's look at a couple of these non-proportional relationship equations, and let's identify a couple key points. Let's identify the slope. Let's identify the y-intercept, and even something called the starting point, which I'm going to talk about right now. And now keep in mind, there's a lot of terminology here. Remember, we talked about how constant went from being called a constant to now being called the slope, right? Whereas even this y-intercept also has another name. It can be called starting point. It can be called initial value, right? But these are important things for us to recognize, especially when we look at the equation or when we look at the graph. So let's look down at independent practice 1. So I'm going to do number 1 for you, and then I want you to pause it and do number 2 and 3. And I will not go over 2 and 3 with you here, but I'm hoping that after I do number 1, it will give you a sense to understand how to approach number 2 and 3. And I want to give you warning on number 3 for the slope. Remember, the slope is whatever number's in front of x. So number 3, you may not see a number that's in front of x, but there is a number there. And I believe we talked about whenever you see x alone, just like that, the number that's in front of it, the coefficient is 1. So it doesn't mean that x equals 1, but it means the number in front of x is 1. But let's look at number 1 on the independent practice, which I'm going to do for you, and then I want you to do 2 and 3. Number 1, first thing I want to do is identify the slope. Now, our slope is always the number in front of x. So in this case, we see this number right here. If you say 2 here, that's not right. If you say 2x, that's not right. If you say negative 2x, that's not right. The slope here is just negative 2. It is the number in front of x. Notice I include that negative sign. I also like to write the slope as a fraction, so that way I can recognize, okay, what is it telling me to do when I go to graph it? And remember, we can write any whole number, any integer as a fraction by putting it over 1. So we take our negative 2, we put it over 1, and now what we're end up doing is say, okay, what is it telling me to do? It's telling me go down 2, and of course we're moving to the right 1. Okay, that's our slope. But what is the y-intercept? What is our y-intercept here? Now remember, the y-intercept is the letter b, and if you remember the actual equation that we're going to be looking at, it's actually in the form of y is equal to mx plus b. What does that mean? That means m, which is our slope, is the number in front of x, and b is the number that's all the way off to the side by itself. So in this case, b is 4. Now I want to bring something attention to you, because if you look at number 2, you see it says minus 4. Whatever number is there, that's what our b is. So for example, number 2 is not going to be a positive 4. You need to make sure that it includes that negative. So it's going to be a negative 4 for number 2. Now, y-intercept, and I want you to write this on your papers, right? This is our starting point. This is a major, major deal. The y-intercept is where we're starting when we go to graph it. But Ms. Woodford, I thought you said we was going to start at the origin. When we deal with proportional relationships as in our Bell work, which is in the form of y is equal to kx, we do start at the origin. But when we have a form of y is equal to mx plus b, like all of these have, we need to start at wherever b is. So we're going to start at this starting point, which is b. Now, what does that mean? Right? What does that mean? If I were to scroll up again at our y-intercept, right, I want to identify, well, what is the point right here? What is this point, right? What would this be if I were to say, okay, can somebody tell me the x and the y value of where that y-intercept is? And this is a big deal. When we talk about the y-intercept, what is the x value all up and down this line? Does the x go over here to the negatives? Does it go over there to the positives? No, it doesn't move at all. X stays at 0. So our x value for this point or any point on this y-axis is always going to be 0. Okay, so when we look at this starting point, and I want you to know this is a major, major deal. Let me actually write this, and I don't know, I'll write this in the color red just to make sure it pops out. Okay, our starting point is always 0, comma, b. 0, comma, b. So whatever our b was, right, that's going to be our y value, and our x value we know is always going to be 0. So when we're identifying the starting point of our graph, which should be on the y-axis, we need to say, okay, x is going to be 0, and the y value is going to be whatever the y-intercept was, which in this case is 4. So that's how I'm going to start off by, as these are our first things that we always want to do before we go and graph an equation. Identify our slope, identify our y-intercept, identify that starting point. From those 3 things, we can say, okay, we're going to be successful with graphing the equation. Do me a favor, pause this video now if you need to, and begin to work on 2 and 3. I am not going to work on it with you, but I do want to go on to the next portion of the worksheet. Okay? All right, let's move on to the next part of this worksheet. Now, this part I've done in class, and I want you to do it as well. I want you to analyze the graphs. When you look at this proportional graph, and when you look at this non-proportional graph, what do you see? What are the similarities? What are the differences, right? Really, I'm looking at what are the differences? What really makes these two different, right? When I look at the tables, what's the same? What's different, right? When I look at these equations, y equals 3x and y equals 3x equals 4, what's the same and what is different? Notice the left side, all of these things, this graph, this table, this equation, they're all proportional. Notice the right side, this graph, this table, this equation, they're all non-proportional. What is the same and what is different? Take a second, analyze them, pause the video if you need to, and see if you can figure out what's the same and what's different in these situations. And then what I want you to do is I want you to write your answers down here with some detailed sentences. In your own words, what do you see visually that's the difference between these two? Okay, and then the same thoughts, think about how you can tell the difference between the graphs and the tables and the equations of a proportional and a non-proportional. Okay, now I'm not going to give you a full answer to write at the bottom, but I am going to point out some things I see. That way you could at least have some added stuff to what you're writing on the bottom there for your what you're explaining. What I see visually from the graphs is I see this. I see this one here starts at the origin. This one here doesn't start at the origin. It starts up here on this something called the y-intercept. Okay. Sorry, getting a little sloppy here with my writing. I apologize. Okay. I also see on the tables, I see this one starts at 0, 0 here, 0, 0, time, 0, distance, 0. But this one here is saying no matter if you moved or not on the time, you're already getting a head start of 4 distance. So I see that this has 0, 4 and this has 0, 0. And we're going to talk about this in our next lesson of how to turn these points on a table into actual coordinates, right? And this is what I see here. And lastly, in my equation, I see this one doesn't have anything. It has nothing afterwards, but this one has plus 4, right? I see this is in the form of y is equal to mx plus b. And I see this one's in the form of y is equal to kx. Okay, so take these things and write a nice explanation of what's the difference, what's the similarity, how to tell the difference between the two, because it's important that you can analyze them and say, okay, that's what I'm looking at. This means that this is proportional. This means this is not proportional. And it's a big, big deal. And I do want you to get better at identifying these parts of the actual graph, okay? So after you finish writing down, if you need to pause it, please do so. Finish your writing up. Let's go on to the last page that I'm going to go over with you. And then I want you to do the rest of the worksheet on your own, okay? Last thing. I want to model for you how to graph these non-proportional relationships, okay? So we've talked about identifying the slope, the y-intercept, the starting point, but now it comes to the place where I say, let's see if we can apply that knowledge to an actual graph to actually properly graph them. I want to graph both A and B with you, and then I want you to work on the pair share as well as the rest of the pair share independent practice homework by yourself. And I believe there's even an exit slip for you to do in this lesson as well. Okay, so let's do the slope together. First thing I'm going to do is identify the slope of both. For the sake of it, let's do this first one in purple, and we'll do the second one in a different color. Okay, the slope here is 2. It's always a number in front of x. I told you guys I like to write that as a fraction. That means 2 over 1. Because it's a positive 2, it means it goes up 2. And of course, we're always moving to the right. The y-intercept here is the number by itself. It's always plus b. Y is equal to mx plus b. So b in this case is a negative 2. Okay? Do not just put 2. It also has to include the sign in front of that 2, which is negative 2. Remember, this is our starting point, right? These two are connected to each other. These two are connected. So I'm saying to myself, okay, well, what is my starting point here? I'm starting at the point where, remember, it's always 0, comma, b. So 0, comma, negative 2. Awesome. Now, this is our information. We got the slope. We got the y-intercept. Let's go and graph this. Now, do we start at the origin here? No, we don't. This is not a proportional relationship where it's y is equal to kx. This is y equals mx plus b, which means we have to start at b. Now, our starting point says we start, and this is why we identify what is that starting point, right? That's a start. This is our starting point. So where should we start? We should start at 0, comma, negative 2. So I'm going to go 0, which means I'm not moving at all on the x, negative 2, which is down here. And it should be on this line. If you're not starting on this y-axis, you're not in the right place that you're starting at, okay? So we start at 0, negative 2. Now, what does the slope tell us to do? And this is why I drew those arrows, and I drew it and say, okay, it tells me go 2 up, 1 to the right. So I'm going to go 2 up, 1 to the right. I'm going to count 1, 2, 1 to the right. And I'm going to keep that pattern going all the way to the end of the graph. You want to make sure you go all the way to the end of the graph so that way you can use the full graph, right? And I'm going to go in the reverse. See me go in the reverse. Down 2 to the left 1, down 2 to the left 1, and boom. Right, I made this awesome graph, and what I'm going to do now is I'm actually going to connect all the dots. I'm going to try to free graph it to see if I can make a nice straight one. Not so much, but it's okay. I'm drawing my arrows at both ends, which is telling me that this graph keeps going on and on. The last thing I'm going to do here is I'm going to label it. You got to label your graphs. This graph is called y is equal to 2x minus 2. Okay, that's what this graph is. Boom, we're done with this one. Take a second if you need to, pause the video, right? Rewind it if you need to see what I did, but take a second to try to do it. I'm going to do one more with you right now. So if you want to just keep watching and say, okay, maybe I'll get what I missed right here, that's perfectly fine. First thing we're going to identify is the slope, the y-intercept, and the starting point. So the slope, once again, is the number in front of x. So would it be 3? No. Would it be 2? No, it's going to be that fraction, 3 over 2. This tells me it goes up 3, to the right 2. What is my y-intercept? It's that number by itself over there, which is minus 4. Okay, I can identify that as a starting point to say, okay, remember x is always going to be 0, and then whatever b is goes next. In this case, it is going to be 0, comma, negative 4. Okay, now the next thing I'm going to do is I'm going to start to graph this. I start at my starting point. So I say, okay, 0, negative 4 is right here. Put a nice mark there. Now, remember, obviously I'm using purple and red. I'm using different colors. You're just going to have to make sure you label yours. I know you're using pencil because you all should be using pencil, not pen, right? Use pencil and then just label yours, and I will know exactly what I'm looking at, right? Exactly where you may have messed up, okay? After I did this, remember to follow the slope of this equation, not the slope of the other equation. Don't do 2 up over 1. Do 3 up over 2. So I'm going to count 1, 2, 3 over 2, new point right there. I'm going to do it again, up 3, 1, 2, 3 over 2, new point. And I'm going to keep doing that until I get to the end of the graph. Up 3, 1, 2, 3 over 2, okay? And I'm going to go backwards, down 3 over 2, down 3 over 2, okay? And you'll notice that they do cross right there, and that's fine. Your graphs will cross at some time. Sometimes they're going to make a V, sometimes they're going to make an X, sometimes they're going to make something that looks like this. It's okay, as long as you followed your slope correctly and you start at the right point. There's no fault in what you did, okay? And keep in mind that both of these graphs keeps going, so it just tells you, and I'm going to try to free sketch this one as well, a little bit better, okay? It tells you that these graphs keep going, so that's probably just where they cross for the first time. And I'm going to label this, y is equal to 3 over 2x minus 4. Okay? And this is how I graph these non-proportional relationships. At this time, if you need to pause the video and rewind it, if you need to take the notes, please pause and take the notes. But I'm hoping that you had an excellent time. I had a good time with you. And I'm looking forward to seeing you on the next lesson. Have a wonderful day. Bye-bye.